In this video, we will learn how to plot some data by using Matlab. In this case, I have already created a script file. It is called nplot. And in this file, I am going to create some data. And so I will enter X and Y data. So for the x-axis, I will put in numbers separated by semicolons for each piece of data for this column vector x. So I can put in 0, 1, 2, 3, and then I can put in y equal to 0, 1.2, 3.9, and 8.5. Now, if that was all I entered, I could use the plot command, and I could put in that I want to plot x on the x-axis and y on the y-axis, and I could save that, and then I could run it. And you will see that it has plotted that data by using lines. Now, it might be that that is experimental data, and so instead we would prefer for those points to be just symbols. So we can add to the plot command perhaps circles. So the letter O, lowercase o, in single quotes, and we can save that and run that again, and you can see that now just the data points are being plotted in the graph. If we want to change the color, of course we could add a color right in front of the symbol. So for instance, if we wanted black, it turns out that the symbol or the code for the color black is K. And so I could save that and run it again. And now you see the symbols have changed to the color black. Now, if I also add a dash after the O, that will say that I want not only the symbol but the line also. So it is possible to do that and run it again. And now you see the symbols plus the lines being shown in the picture. Well, since that's data, we don't want the lines in this case, so I'm going to take that away. And what I'm going to do is I'm actually going to plot another thing on the graph at the same time. And so I want to be able to plot the data and then keep that data on the graph. So I say hold on, so that holds or keeps the graph in the on position or on mode so that we can add additional data. So let's suppose I define now another variable called x1, and I am going to define it to be the values between 0 in increments of 0.2 all the way up to 9. Actually not 9, I actually want to go to 3. And I'll put a semicolon at the end of that. And I believe that that will create a row vector. And let's check that out. I'm going to copy it, put it in the prompt down below, paste it, and I'm going to hit return. And you see it prints this out as a row vector. Well, maybe I want that instead to be a column vector, and so I can add an apostrophe at the end of this. And so then if we were to copy that and paste it down below and run it again just in the command prompt, we would see that now it created that as a column vector for the variable x1. Now then, I want to use that and define a function which could be x1 to the second power. So I'm going to take the vector x1 and square it. However, if you do it this way, it's not going to know exactly what to do because you're trying to square this column vector. Really what you need to do is, in Matlab, add a dot before the mathematical operation. And what this will signify is that Matlab understands that what you're saying is you want to create a column vector y whereby you take each individual row in x1 and take those individual elements and one at a time square them. And so if we do that, then we're going to get what we want there. So we need to have that little dot there. And now I can plot this also, which will be x1 comma y1, and I am going to use red, and I want it to have no symbols, and so I'll just put a line, and I think this is going to work for us. So let's try it and see what happens. If we run that, we get not only the symbols, but we also get this function of basically y1 equal to x1 squared. And so we can see in this case I'm trying to depict what maybe is the theoretical line versus the data that didn't quite match during our experiment but was close to the theoretical line. And so then we can also add a additional information. For instance, we could put an X label here, and we can put a title for the X information, and perhaps that is time, and so we could put that in here as time t in units of seconds. And we could also enter the Y label, which maybe is distance, d, in units of perhaps feet. We could also put a title, and we could of course come up with a sensible title, and of course that would have to be appropriate for whatever experiment and whatever the information being depicted in the graph would be. And so we could just in this case put a kind of a generic title, experimental results. And lastly, we could even add a legend. In this case, we plotted first the data, and so in our legend we would put in the data title, whatever that might be, and then we would put in and in fact maybe that's the experimental data, so maybe I could put in that there, and then I could also put in the legend the theoretical line or curve perhaps, and we could end that. Now if we run it that way, it will automatically choose where it's going to put that legend for us. So let's see what happens and if we like what we see. So now I've run that, and you can see it's added the X label, the Y label, the title for the overall graph, and even this legend for what we're seeing in this graph. Well, sometimes this experimental, or I should say this legend, is overlapping the curve. Maybe we would prefer for that legend to be over at the left, or maybe in the bottom right corner. And so it turns out that we can add a command to this legend command, and we can put in a location to say that we want to now specify the location, and then after that command of location we're going to put southeast. And this will put it in the bottom right-hand corner of the graph for us. So if we now run this again, we will see now that the legend was put in the bottom right-hand corner. So now this is a simple introduction to how to do some plotting in Matlab, and hopefully that will be helpful to you.